How do you feel right now? How do you feel right now? I hope you feel very energetic, excited and awake to hear my lecture today entitled Smart Polymeric Membranes, Treat the Waste and Mind the Goal. I am Muhammad Johan bin Zahari, or you can call me Johan Zahari, from the Faculty of Science and Technology, Universiti Kebangsaan, Malaysia. This is the map of the Southeast Asia region. And do you know, the Southeast Asia is considered the largest palm oil producer in the world? Indonesia, Malaysia and Thailand are the leading palm oil producer, while Malaysia has producing up to 32% of the world palm oil productions. Together with Indonesia, both of these countries has producing more than 3/4 of the world palm oil productions. Very huge, isn't it? If we can focus on the Malaysian palm oil, we can see that the demand for Malaysian palm oil is increasingly significantly annually, as can be observed from the graph. This graph shows the annual productions for palm oil from the year 1975 up to 2015, with a sharp peaking in the year 1997, in which continued steadily upwards. Now, let me explain to you a brief about the palm oil process. This is the typical palm oil tree that you will see all over the world. After this palm oil tree, you will have the palm oil fruit bunch. After this palm oil fruit bunch, we'll have this palm oil fruit. However, this palm oil fruit is very unique because it can produce two types of oil. The first one comes from the mesocarp, in which it will produce the palm oil. The second one comes from the palm kernel, in which it will produce the palm kernel oil. However, throughout this process, from the palm oil tree itself to the palm oil itself, can you imagine how much waste are generated? Can you guess? 70% of waste is generated just to produce this palm oil from this palm tree. Very huge, isn't it? The palm oil waste can be divided into two, the solid waste and the liquid waste. The liquid waste is considered dangerous to the environment if not treated well. This is because inside this liquid waste contains the palm oil mill effluent, or what we call as a pomade. As a whole, the palm oil industry can cause environmental pollutions through global warming, biodiversity loss, and water pollution. This is the typical treatment plant of palm oil. Number 1 shows a series of terrace ponds in which each of the ponds have their own specialized functions to treat the pomade, such as the alkali treatment. Number 2 is the slush ponds, where all of the particulates matter and suspended solid is being removed from the pomade. Number 3 is the anaerobic tank, is where all the methane gas liberated is being collected and fully utilized. And number 4 is the final pond, is where the pomade is being kept. Although there are series of treatment before the pomade reaching the final pond, however, the characteristic of the final pond inside the final pomade inside the final pond is still considered dangerous to the environment. This is because the palm oil mill effluent contains 95% of water, has high value of biological oxygen demand (BOD), chemical oxygen demand (COD), and total suspended solid (TSS). It is yellowish in color and have a very foul smell. This table shows the characteristic of pomade listed by MPOB and the discharge standard proposed by the Department of Environment. The value is not comparable. This is because, as an example, for the biological oxygen demand, you can see that the range listed by the MPOB is between 12,250 up to 43,750. However, the discharge standard proposed by the Department of Environment is only 100 mg per liter. This has shown that this conventional method is inefficient to treat the pomade. Furthermore, the conventional method of effluent treatment may cause in air pollution, water pollution, and soil pollution. As for the air pollution, the anaerobic process that occurs inside pomade will release a methane gas to the atmosphere, and this methane gas has 21 times global warming potential compared to other gases. Since the final pond is inefficient to keep the pomade, some of the pomade might be absorbed by the soil and some of it might be leaked to the stream. Before the anaerobic process occurs, aerobic process will occur. During this process, an oxygen depletion will occur inside the water body, and in the long run, this will cause a water pollution, indirectly a soil pollution. The problem faced by this conventional method is that it does not meet the standard requirement proposed by the Department of Environment. It can cause a pollution, and it requires a long time for treatment. So the question now is how to overcome this problem. Inspired by our kidney has the functions to filter out all the nutrients needed by our body and to excrete all the toxins that are not needed by our body. This kidney has the same function as the membrane. So why I choose membrane? A membrane is a thin layer which has the properties of high selectivity for separating solid, liquid and gas component. This is the typical membrane layer which have an active layer, and some of the membrane might have a supporting layer. Let's say you want to filter a molecule. By using a certain amount of pressure, you will be able to filter the molecule accordingly to the size of the pores of the membrane. This has concluded that the membrane has a smart properties in which it is able to separate based on the molecular size, and some of the membrane is able to separate based on the molecular charge. The membrane can be classified into four, starting from the microfiltration, ultrafiltrations, nanofiltrations, and reverse osmosis. Let's say you have a brackish water and you want to drink the brackish water. You might need to use the help of microfiltrations membrane because this membrane is able to remove all the particulates and bacteria that contains inside the water with a pressure of 0.5 to 5 bar. However, some of the water might contain the viruses such as E. coli and everything and all the micromolecules. So you need to use the aid of the ultrafiltrations membrane. This membrane is able to remove all the micromolecules and microorganisms, including the viruses that contains inside the water, with a pressure of 0.5 to 5 bar. If we go to a smaller size of the membrane, that is nanofiltration membrane, this membrane has the pore size from 10 to 1 nanometer. This membrane is able to remove all the divalent and multivalent ion. And lastly, the most popular membrane, that is reverse osmosis membrane. Reverse osmosis membrane has the pore size from 1 to 0.1 nanometer, and this membrane is able to remove all the monovalent ions, or in other words, this membrane is able to remove all the nutrients that contains inside the water, such as the potassium, sodium, and calcium that contains inside the water. And if you might realize, in our housing area, our parents or our neighbors are installing the reverse osmosis membrane just to filter out our drinking water. Without you are realizing, this reverse osmosis membrane has the capability to remove all the nutrients that is needed by our body. There are several alternative methods that is using this membrane to treat the pomade. However, the method that is using by them are using the pre-treatment prior to membrane treatment. So today I chose to highlight the best three of the treatment. In 2003, Ahmad has coupled the usage of membrane treatment with coagulation method, and the BOD reduction is up to 98.8%. In 2012, Azmi, Yunus and Zakaria has coupled the usage of membrane treatment with the sand filtration and coagulation treatment once again, and the BOD reduction is up to 95%. While in 2014, Azmi and Yunus has coupled the usage of membrane filtration with an adsorption treatment for the pre-treatment, and the BOD reduction is up to 63.3%. The advantage of using this alternative method, that is the membrane method, compared to the conventional method, is that this membrane method requires very less space, it is low in energy, it is continuous process and easy to operate. However, some of the commercial membranes right now having a limitation in which they are not chemical resistant, they have low mechanical properties, they are high cost, they have low separation rate, thus they require all this pre-treatment. Now we go to my membrane, that is ENR PVC cellulose membrane, and how do I prepare this ENR PVC cellulose membrane? I chose ENR as the basis of my membrane. ENR comes from the latex, in which we can tap from the rubber tree. I introduce the epoxide group inside the latex until it becomes ENR. ENR has the properties of flexibility, abrasion resistance, polarity, which we can relate with the hydrophilicity, elastic, and it is a natural resources, so we can find it abundant. The usage of ENR is being coupled with the usage of PVC, in which PVC has the advantage of durability, oil and chemical resistant, and it is a thermoplastic element. Furthermore, PVC is being widely used in the industrial area. The addition of ENR and PVC will produce an ENR PVC membrane which has the properties of high compatibility and high mechanical strength. In addition, the mixing between this ENR and PVC will form a membrane that possesses both of the ENR and PVC properties, that is thermoplastic elastomer, or what we call as TPEs. To enhance the performance or efficiency of this membrane, i.e. the cellulose, in which the cellulose can come from the latex tree, the rubber tree, or the cellulose can come from the palm oil tree itself. The cellulose has the advantage of high mechanical strength, hydrophilic, it is very renewable, hygroscopic, and it is a natural resources. So the advantage of ENR PVC cellulose membrane compared to the commercial membrane, that is, this membrane requires no support, they have high mechanical properties, they requires no additional chemical and low cost because we are using the natural resources and they are very porous and can take wastewater efficiently. Now we go to the effects of addition of cellulose to my membrane. First we go to the surface morphology. This is the ENR PVC membrane without the addition of cellulose. We can barely see any pores is being formed either on the surface or on the cross-sectional area of the membrane. Now look, after I introduce cellulose inside my membrane, you can see that the percentage of pore is increasing while the size of pore is increasing either on the surface or on the cross-sectional area. This is so interesting. As for the porosity and absorptions, the ENR PVC porosity and absorptions before adding the cellulose is between 10 to 16. After the addition of cellulose, I have doubled the porosity and absorptions of ENR PVC membrane. Now, for the contact angle, before the addition of cellulose inside my membrane, we can see that the contact angle is 86. After the addition of cellulose inside my membrane, I can see that the contact angle has reducing to become more hydrophilic, that is 69.8. This is making this membrane has more affinity towards water compared before the addition of cellulose. Now we go to the pomade discoloration or decolorization. This is the best part because what matters the most for the pomade is if the pomade lost their color, the water is considered treated. Now we go. A is the colors of pomade before the treatment. B is the colors of pomade after the treatment. By using ENR PVC cellulose membrane, we are able to remove the colors of the pomade. The removal of colors might be due to the removal of the suspended solid and removal of dyes from the fruit itself. Now we go to the membrane before the filtration. We can see that the surface is kind of like clear, and after the filtrations, we can see that on the surface, a sludge accumulations that occurs on the membrane surface. If we magnify the sludge accumulation, we can see that all the micromolecules, microorganisms, and viruses is being trapped or retained on the membrane surface, thus has enhancing the BOD reduction up to 78%. This has shown that this membrane is capable to compete with the previous study, which is using the pre-treatment prior to membrane treatment. So we can conclude that for the addition of cellulose only, the addition of cellulose has enhanced the pore formation, the addition of cellulose has decreased the contact angle, and the addition of cellulose has increased the hydrophilicity of the membrane. As for the outcomes, if we can separate the 95% of water that contains inside the pomade with the 5% of unknown substance that contains inside the pomade, we can use this water further for industrial use such as for the cooling tower and electricity generation. And in some cases, if we might able to remove all the colors, the water can be used for drinking water. Interesting, isn't it? And this 5% is where the goals come from. This 5% contain all the amino acid, fatty acid, and minerals that contains inside pomade. If we can direct or channel this 5% for a chemical treatment, we can use this 5% for pharmaceuticals, cosmetic, soap, and food industry. This is where the term treat the waste and mind the goals come from. Imagine this is only for one plant. In Malaysia, we have more than 600 plants that operate in the palm oil industry. Can you imagine how much gold that we can mine throughout this process and how much water that we can save just throughout this process? Very interesting, isn't it? So, as a conclusions to my presentations today, the usage of ENR PVC cellulose membrane is able to fully utilize all the permeates and irritants of the waste corresponding to the title Smart Polymeric Membranes, Treat the Waste, and Mind the Goal. Thank you very much.